Okay, for this video, I'll be going through pure physics moments, success criteria D. Now, apply the principle of moments to new situations or to solve related problems. So, the principle of moments definition was actually covered in success criteria C. Now, in order to apply the principle of moments, look out for keywords in questions that states that the system or body is in equilibrium, balance, or stationary. So if all these are not mentioned and you don't know if the body will be in equilibrium or in balance or not rotating, you cannot use principle of moments. Okay, so the steps will be, firstly, you need to identify where the pivot is. This is the most important step, right? Because the pivot will be used as the reference point, okay, for which all the perpendicular distance is to be measured with reference to. Okay, then second step, it may seem very simple. Identify number of forces acting on the body, which is on the body, right? So the number of forces will then give rise to the same number of perpendicular distance. So if I have this, let's say 3 forces acting on the body, then by right I should have 3 perpendicular distance of the line of action of each force to the pivot, and therefore there will be the number of moments. Okay, so if I have 3 forces, then they will generate 3 moments. Now for each force, step number 3, determine the perpendicular distance of the line of action of the force to the pivot. Okay, so this is actually the most important and difficult step. Okay, so number 1 is the basic step. You need to know where's the reference point. And number 3 is where usually students will make mistakes. Number 4, calculate moment for each force. This is easy because moment equals to force times perpendicular distance. Once you have the force and the perpendicular distance, this is easy. Now, step 5, also quite easy. Assign direction for each moment. So it's either clockwise or anti-clockwise. Then step 6, if they mention that the body is balanced, stationary, or in equilibrium, then you're allowed to apply principle of moment, which states that the sum of clockwise moment equals to sum of anti-clockwise moment about the same pivot. Now this is the condition for equilibrium, so you need to memorize it. So the resultant force on the object is 0. That means the translational motion is 0. And the resultant moment on the object is 0, so rotational motion is 0. Which means the first one is actually F net equals to 0. Second one is moment or net moment equals to 0. Okay, let's use an example to practice the 6 steps. So we actually have a uniform rectangular board. So if it's uniform, that means the center of gravity, which we haven't gone through yet, will be in the center. That means there will be the weight. The weight will actually be at the center of gravity. But in this case, we will not care about the weight because the weight actually passes through the pivot. It says that X is a pivot. Okay, so this force of weight actually passes through the pivot, so there won't be any perpendicular distance. Okay, but we'll talk about it in more details later. Okay, so step 1, this is the pivot. Okay, because step 1 is identify where the pivot is. Step 2, I need to know how many forces are there, so I'm going to put my step 2 here. I will actually have 3 forces. Okay, although some students will say there's actually weight also acting on the board, okay, but because the pivot is at where the weight is acting at, so there's no perpendicular distance. So just for easy practice here, we'll just not consider the weight. Okay, so since we have identified 3 forces, then there will be 3 perpendicular distance. Okay, now in order to identify the perpendicular distance of each force's line of action to the pivot, we need to draw the line of action for each force. Okay, so let's start with the 10 Newton. Okay, so very easy. We just extend the force with dotted line front and back. Okay, and because the pivot is over here, this will then be the perpendicular distance for the 10 Newton. Okay, and since we know that this board is 8 meter by 2 meter, and it is in the center for the pivot, that means the perpendicular distance for this 10 Newton is 4 meters, right? This distance will be 4 meters. Okay, so I'm going to do the perpendicular distance for the 5 Newton now. So first thing, you extend the force front and back to have its line of action. So as you can see, if the pink color dotted line is the line of action of the force and the pivot is over here, this will then be the perpendicular distance. So like I said, step 3 is actually the most difficult. Okay, but if you try at least to draw the line of action of the force and draw it to somewhere close to the pivot, you'll know that the shortest distance will then be the perpendicular distance. Okay, and this will allow it to have a perpendicular distance of 1 meter because it's 2 meters, half of it will be 1 meter. Okay, now I'll do F. So I draw the line of action of the force of F, front and back. Okay, and pivot being here, so this will be the perpendicular distance, and it's also 1 meter. Okay, so I'm going to label all this as step 3 because step 3 is about finding the perpendicular distance of the line of action of each force to the pivot. Okay, so once we are done, then we can do step 4, moment equals to force times perpendicular distance. Let's do it for the 10 Newton. So it's 10 multiplied by 4. So we get 40 Newton meter. Okay, and for the 5 Newton, moment equals to force times perpendicular distance again. So 5 times 1, so we have 5 Newton meter. Okay, and for the force F, the moment will be force times perpendicular distance. So I'll leave it as F multiplied by 1, so it is F Newton meter. Okay, so once we have calculated the moments, we can then find the direction of each moment. So this is where you apply the pen trick, right? Whereby, example for the 10 Newton meter, right? So the pivot is here, you hold the pen in the center, then you apply a force on the right hand side of the pivot. Okay, because this is what the 10 Newton looks like. Okay, and you know that if you hold it in the center, you push downwards on the right hand side, it will go clockwise. So this will be clockwise. You apply the same thing to the 5 Newton force. Okay, it will then be also a clockwise, and F will then be anti-clockwise. Okay, so this is step 5, finding the direction of each moment. Okay, it's no longer about the force, it's more like what is the direction of the moment. Okay, but you still need to know where to apply the force. Okay, and you still need to know where you hold to simulate the pivot. So step 6 is actually your principle of moment. So we take all the clockwise moment, which is 40 Newton meter and 5 Newton meter. Okay, actually I don't need this. It will be equal to the sum of anti-clockwise, which is only F. So therefore, F will be 45 Newton. Okay. Okay, D2. A load is to be moved using a wheelbarrow as shown. The total weight of the load and wheelbarrow is 600 Newton. So over here, 600 Newton and acts at 1 meter from the pivot. Now, what's the size of force F needed to just lift? If it's just to lift, then we can say that it is applying, we can apply principle of moment. We just lift it and just hold it there. Okay, so we have the force F here, right? So again, we do the 6th step. Okay, so the first step is finding the pivot, which is here, the pink dot here. Second is how many forces are there. We have F and we have the combined weight, which is 600 Newton. Okay, third is to find the perpendicular distance. Okay, so let's do for the 600 Newton first. We see that the pivot is over here and we draw the line of action of the force for the 600 Newton. So this will be the perpendicular distance of 1 meter. So I put 1 meter here. And this is step 3. Okay. For F, it's a little bit more complicated. But again, let us just draw the line of action of the force. Okay. And since pivot is here, this will mean that this is the perpendicular distance. Right, because I'm having the line of action of the force here, and the perpendicular distance will be the shortest distance between the pivot and the line of action of the force. Okay, so we'll need to use Pythagoras to solve, because it is 1.73 meters right angle to 3 meters. Okay, so the answer will be 3 square plus 1.73 square. Okay, so you'll get a certain value. Okay, so the answer is 3.46 meters. So this will be the perpendicular distance, okay, of the line of action of the force F to the pivot. So this is step 3. Okay, so like what I said, once you are able to get the correct perpendicular distance, half of the battle is won, right? Because then you can go on to calculate your moments. Okay, so for this 600 Newton multiplied by 1 meter, the moment is 600 Newton meter, and for this it will be 3.46 F Newton meter, putting in the units. Okay, then now let us find the direction. So this is step 4. Okay, so step 5 is to assign the direction. So for the 600 Newton meter, right, it is going downwards on the right hand side of the pivot, so it will cause it to be clockwise. Please hold a pen on the left tip of the pen and then press down on the right side of the pivot downwards. You will make the pen turn clockwise. So this will then be anti-clockwise. Okay, so this is step 5. Okay, and just now we say that we can use a principle of moment, so we will assign clockwise equals to anti-clockwise, so 600 equals to 3.46 F. Therefore, your F will be 173 Newton. Okay. Okay, D3, now that you understand how to apply the 6th step, D3 is slightly more difficult. We see that we have a uniform iron rod. That means there will be weight right smack in the center because it's uniform. That's where the center of gravity is. Okay. This rod is 50 cm in length and mass 5 kg. So this means that the M is 5, right? And since W equals to mg, it will be equals to 5 times 10 equals to 50 Newton. So I convert it to the weight. So the weight is 50 Newton, and this is one of the force acting on the iron rod. Now it's suspended by 2 strings P and Q as shown. So the tension in P and Q, let's call it tension Q, and it must be pulling the iron rod up, right? And we have tension P, again pulling the rod up. So now this is a case whereby we have more than one support point, more than one pivot. Okay, so this is very important. The force that passes through the pivot will have no moments. So it doesn't mean that there won't be any force. It just means that the force, the line of action of the force will actually pass through the pivot. And if it passes through the pivot, there's no moment because perpendicular distance will be equals to 0. So now you have to make a choice. Should we make the point P over here or point Q to be the pivot? It doesn't matter. So in fact, I can actually do 2 of the same steps. Okay. So this is a very common question in O level. So maybe I'll make point P the pivot. Okay. So I'll be using blue in color. Okay, so if I make point P the pivot, that is my first step. Alright, and there are 3 forces, TP, W, and TQ. Okay, so this is step 2. Step 3, I'm supposed to find the perpendicular distance of the line of action of each force to the pivot. So step 3, TP will be 0, right? Because line of action of the force TP passes through the pivot. Okay, for W, it will be, because it's situated in the center, so this is at the 25 cm mark. So from the weight all the way to the pivot at P, there's a distance of 20 cm. Okay, so for TQ, it is at a distance of 35 cm. Okay, So this is step 3, and this is the most difficult part. And step 4 is to find the moment. Since TP multiplied by 0, the moment due to force TP will be 0. For this will be 50 multiplied by 20. Okay, there's actually no need to convert it to meters, to SI unit, because if everything is in cm, everything will be cancelled out, will work out fine. Okay, so this is step 4. For this will be 35 TQ, right? You apply the formula, moments equals to force times perpendicular distance. Now step 5 is to assign direction. So if the pivot is over here at P and W is acting on the right hand side and is going downwards, it will be clockwise. So this is step 5. For TQ, the moment due to TQ, it will be anti-clockwise. And since this thing is in equilibrium, so I can apply principle of moment, okay, whereby clockwise equals to anti-clockwise. So 1000 equals to 35 TQ. So actually TQ will be equals to I'll get 28.57, and since this is MCQ, I see 29, so TQ will be 29. Okay, right. So what if somebody wants to make a point Q, the pivot? Okay, so we make point Q the pivot, but let me just erase everything here. Okay, so we still have TP, and we still have W right smack in the middle, which is actually 50 Newton. Okay, so what if I make point Q the pivot? Okay, so that's step 1, always find the pivot because that's the reference point. So step 2, how many forces are there? We have TP, we have W, and we have TQ. Same thing, right? So for TP now, because it is not having the pivot at its point of application, right? So the distance is, for step 3, the perpendicular distance will be, is it 35? Yeah, I believe so. Okay, 5, 10, 50, yes, 35. Okay, so for W, it is at a 25 cm mark, so it's 15, right? 15 cm away. Okay, so that's our perpendicular distance for W. So TQ, now that the pivot is chosen to be at Q, so the perpendicular distance will be 0. Okay, so just like what had happened to TP when the pivot is at P. Then we apply moments formula, so I have 35 TP, and this will be 50 times 15 equals to 750, and then we have this to becomes 0, so we will not write it down. So this is our step 4. Okay, so we have 2 moments, right? But for TP, because it's acting on the left of the pivot, right, and it's going upwards on the left, so you'll make it, turn it into clockwise. Step 5, finding direction. For W, it will be anti-clockwise. The moment due to W will be anti-clockwise, right? Use the pen trick, simulate where the pivot is, and then press the force according to where it's being applied in the question. So part 6, we can actually use a principle of moment. So 750 equals to 35 TP, and then TP will be 21.4, but since it's given as 21, so that's the answer. Okay, so answer is B. Okay, so actually, do we need to work out the two TP and TQ using the moments? Actually, we don't need to. Okay, some students actually discover that because the total downward is 50 Newton, so the total upwards must be 50 Newton. That means F net must be 0. Remember, the conditions for equilibrium is F net equals to 0 and net moment must also be 0. Since we have found one of the force to be initially TQ to be 29, right? So TQ is 29, it is upwards. TP is also upwards. So TQ plus TP equals to 50 downwards, right? So that will then make the net force to be 0. Okay, so since TQ is 29, therefore, if I do my subtraction, I can straight away get TP to be 21 Newton. Okay, and that is the same as doing this moment's calculation twice. Okay. Okay. Now D4, a non-uniform steel rod of 1.8 meters is balanced on top of two electronic balances as shown in the diagram below. The balances show reading of 0.24 kg and 0.26 kg. So what is the distance of center of gravity of the steel rod from NX? So of course it is not 1.8 divided by 2. It may be, but high chance that it won't be because it's a non-uniform steel rod. Okay, so we see that at NX it is 0.24 kg, and that means it is having a 2.4 Newton. How do I get 2.4? 0.24 multiplied by G. W equals to mg, because this is the M, right? So multiplied by 10, I'll get 2.4 Newton. Similarly, on NY, I have a 2.6 Newton acting down on the scale. That means the forces acting on the steel rod is the weight of the steel rod. Okay, and we also have a 2.6 Newton because by Newton's third law, the steel rod presses down on Y with a force of 2.6. The balance will exert an equal and opposite force on the rod. Okay, so I will have two forces, Fx equals 2.4, and I have Fy equals to 2.6, and they are both acting on the rod, which means that the weight is 2.4 plus 2.6, because that's the total weight, right? It's being supported at 2 points, so it's 5 Newton. Okay, so now we know there are three forces acting on a steel rod. Okay, so step 1, because now there are two support points, you have to choose your pivot, and because they want us to know, find the center of gravity, distance of center of gravity of the steel rod from NX, I'm going to make this distance to be the distance that we want to calculate. Let's call it maybe F. No, let's call it D. Okay, let's call this D. Okay, so that is the distance of center of gravity of the steel rod to NX. And I'm going to make the pivot to be at X. Okay, over here. So this is the pivot at X. So this is my first step. Second step, how many forces there are? We have the 2.4 Newton, we have 5 Newton, and we have 2.6 Newton. Right, these are the three forces. So the perpendicular distance, because for the pivot we chose it at NX, therefore the perpendicular distance is 0. Step 3, for the 5 Newton, we call it D, right? And for the 2.6 Newton, it will be at 1.8 meters away. Okay, so this is the difficult part. Once you get this, the rest will be simple, which means the moment will be 0 for the 5N, and perpendicular distance of D, it will be 5D. And for the 2.6 Newton at the end, with a perpendicular distance of 1.8 meters, 2.6 times 1.8, I'll get 4.68. Okay, Newton meter. These are the units, right? Then let us assign the direction. Since it's 0, we don't need to assign direction for the 0 moment. For W, because it's acting on the right hand side where the pivot is, so again, hold the pen up. Okay, you hold the pen here on the left hand side, right, where X is, and then you apply a downward force in the middle somewhere to the right of the pivot. You press it downwards, you know you will turn it clockwise. Okay, so that's the pen trick. So for this, it will be clockwise, and this will then be anti-clockwise. Okay, So now we can apply principle of moment. So 5d equals to 4.68. So my d will be 0.936 meters. Okay, so even for two pivot or two support question, you just choose the pivot, one of the support to be the pivot. Okay, and you will get rid of some of the unknowns. Okay.